So welcome to this class. In this class, we will be discussing on content delivery network, one of the important component of scaled application. And we will be discussing on detail of content delivery network, what exactly delivery network is, and the physics of latency and how CDN solves it, to the response time of any application, how we can reduce that using CDN. Then we will be discussing on the CDN architecture from DNS to Edge. So how the call flow goes when you have CDN and why we need the CDN. We'll discuss all this. Then we will be discussing without CDN how the application look like, and then if we place the CDN, what are the benefits it provides to you. So there are a couple of scenarios and we will be discussing in detail at each layer how the latency will be added and how we can reduce that latency using CDN. Then there are some problems when you deploy any AI application into production. So let's suppose ChatGPT, Perplexity, or Google AI. So they have millions of customers globally, and why CDN require to solve the latency issues. We will discuss this kind of architecture patterns, and then we will see a couple of questions asked in FAANG like companies, and we'll answer that. After that, what are the key takeaways? What are the CDN engineering career path? And what are the CDN tools or technologies available in market? And then we will discuss couple of uh, code practices also. So if you see here, we have some scenario based questions for interview, and there is a semantic essay we will implement. Then we will build our own CDN. This is one of the snip, and how we can apply analytics and monitoring to CDN. So this is all over about this class. So now let's start with CDN. So what exactly CDN is? CDN is a system of distributed servers around the world that works together to deliver website content like images, videos, and web pages to users faster and more efficiently. So if you see a latency, let's suppose a customer, you have a web app or mobile app here, and you requested for some resource. So the ideal path is without CDN, it will request to server, and server will look into either the database or cache, which we have covered in last class. So if the data is available in database or cache, then the data will be returned back to web and mobile application based on the request. Now let's suppose if we have some data which is static data. Let's say we have some web pages like styling CSS or images or videos. So now if we calculate the latency, how exactly it will be. So let's say you are making a request. If you see the latency of DNS lookup, what is the meaning of DNS lookup here is, let's say you are requesting abc.com/a.png, some image. So how the path will look like? So DNS resolver will take some time to resolve the DNS. It returns the IP from here. Then there is a TCP handshake. So let's suppose in DNS lookup, you have added from 20 to 120 milliseconds of time, and then TCP handshake where we have added around 50 to 200 milliseconds, then TLS handshake. So these are the two stages where we are verifying the security, and then request send to server for processing. So here also we are adding some delay or latency to our request. So let's say request send from your load balancer to server. Then also we are adding some latency here. Let's say 10 to 500 millisecond. and then at the end we send the response. So the total response time without CDN, it goes from 200 to 1200 millisecond for simple page load. Any page which resides into either this DB, or let's say if it resides in cache, then we are reducing some time, but still it takes time. So how the CDN solve this problem? So let's understand this. So this is the pain area. So if you see here, this is one of the example. Let's say you have an application. I'll give an example of YouTube, and you have users in India, you have users in Brazil, and you have users in Japan. So how the internet before CDN? How much delay we get in the request if we don't have CDN? So let's suppose you have 500 million customers in India and 200 million users in Brazil, and let's say 120 million users in Japan, and so on. So globally you have customers, and then you have deployed a single origin server, let's say in California. So let's say you have deployed your server at one location. So now all the requests will go to that server in California. This server will serve the request. So if you see here, the distance from India to US is around 13,000 kilometers. If we think about light speed also, it will take around 90 milliseconds, but our internet doesn't work at light speed. So if we talk about our internet speed, then it will take around 250 to 400 milliseconds around. So if our server resides in California and our customers are using from India, so let's say the example of YouTube. Now, what about the customers who resides in Brazil? Again, distance matters. So the real latency will go around 200 to 350 milliseconds. In case of peak load, means we got the request 1 million requests per second. This is called peak hours or peak time. So let's suppose there is a movie released by some very famous, uh, maybe DC or Marvel, and then it is uploaded on YouTube. So everyone is watching. So we are getting a peak load. So this is a consideration where 1 million requests per second you got. And if you see like 10 Gbps bandwidth, if you allow 10 Gbps bandwidth also, then again like server will cache. There is a chance of DDoS attack also for single IP target. So these are the some problems with single origin server which you deploy into one zone. So let's say if you are using an AWS or GCP or Azure, any cloud, and you're deploying your application at single server, that is a problem. It will add more latency to it. So these are the cold hard numbers. Average global latency will go around 350 milliseconds. So it's a globally. So we are just calculating average latency. And if we talk about the availability 99.5, so it's not 99.9 because this is a single server. There is a possibility during the peak hour server may crash due to the workload. Now the bandwidth cost, it will be higher because we have to provide a huge bandwidth. And if you think about the user satisfaction or user experience, which is low because the latency is higher. So you will be keep on waiting for the buffering. So when we were having 2G that time or internet started that time, we used to wait for the web page to load, and it was keep on buffering. So that's the kind of experience we should not provide to our customers. So nowadays, if you see, we have 5G network, and we are able to view movies on Amazon Prime or Netflix without any hindrance. The latency is very, very less. How we have achieved all those things? So this is not because of single server. So if you deploy everything at single server, you will not be able to achieve. So now this is where internet with CDN. So let's suppose you have your customers in India, Brazil, Japan, UK, Africa. Now you put a CDN layer, a CDN edge network. So where it gets connected, this is the diagram you see here. This is connected directly to web or mobile application with the client. So there is no like load balancer or servers come into picture. So there is no node. It's direct communication with CDN. So this is where we have added a CDN edge network. Now this edge network resides in different geographics. So let's say in India, you have in Mumbai, and there's a possibility you can enable CDN in multiple locations also within country based on the availability of our provider. Let's either if you are using Amazon like AWS, GCP or Azure, you can see there, or you have Akamai CDN. So you can view like what are the locations it is available. So this is just an example. So let's say for India, we have enabled in Mumbai. For Brazil, this is one in Brazil, and then Japan in Tokyo, and in London, UK. So these are some like countries we have just written here. For Africa, let's say Cape Town, and this is a global private backbone and interconnected edges. So what happens is the data which you want to load faster for the customer, you will be storing here in CDN Edge network. So this is the layer where you will store some images. Let's say for example, logo will not change easily. Just an example. Let's say CSS files, you can keep there. Images, which is static image. So you are not frequently changing them. Or let's say some videos you want to show the user. This is also not frequently gets changed. Even though if you are frequently changing the content, there is a way to sync. So now let's go back to this diagram. What happens is, now let's say customer asks for the resource and this resource is not available in the uh, CDNS network, then it will forward the request to the server, and this is the transformation will happen. So instead of going into all the nodes, instead of moving into all the nodes, so it will directly call to the CDN, and CDN has all the features implemented for securities. It has DDoS, it has rate limiter, or all the security perspectives CDN supports. So we no need to worry about that. CDN is already having all the features. So you can directly connect with CDN and fetch the data. So this is where we are reducing the latency or the response time of the API. Now let's take this example. Similar, like without CDN, one origin server. So here we have one origin server. Your users either resides in India, your users resides in Brazil or Japan. Everyone calling to US East. This is one of the location of server which you have deployed. Then again latency problem. Right? So what are the factors we should calculate when we talk about the CDN in interview? These are the factors. Why CDN? So if we talk about the physics constraint, so let's say this is the speed of light is the maximum, we can say, the travel for the packet for internet, right? Internet can go till the speed of light. But this is right now we are into 5G. This is very, very, very far from there. So physics constraint, speed of light limiting, this is maximum, I say. Based on your network, it depends. It varies. Now, another physical constraint is the distance between your users and your server. So let's say your user resides in China and you have enabled your server in US. Again, distance matters. So this is somewhere we are adding a latency, a response time. Another is bandwidth economics. Let's say 10 Gbps server connection at the data center cost around 5,000 per month, right? So let's say if we enable the bandwidth more into server, then it cost huge. Instead, CDN cost is lesser for the bandwidth, for the network which we provide to the get more connections to it, right? Then this is about the physics, this is about the economic, like bandwidth. If we provide more bandwidth to the single server, definitely it require a more hardware, and if require a more hardware, the cost will increase. Another problem is resiliency. So your system is not resilient. What is the meaning? Let's suppose in case your server is down. Now what will happen? There is a single point of failure. No response at all. But if you have CDN with you, in case your edge CDN goes down from Mumbai, it will be served from other locations, nearby locations. So how it happens that we'll discuss in the detail. But as of now, there is a backup. If all the CDN down, then it will go to the origin, the source. So there is a resiliency, or your system is resilient now. There is no single point of failure. And security. So it has all types of security enabled in CDN, distributed attack and surface. So we will discuss about those securities like DDoS attack or rate limiting, all those things. So let's take one example of interview question. So how in an interview they can ask the questions and you can reply with CDN. So the question is, a user in Bangalore requests a 1 MB image from a server in Virginia. So your server deployed in Virginia. So you need to calculate without CDN and with CDN the total time. So this is where the interviewer understand your understanding on the request response latency. So what are the constants you should consider? We have also discussed with the diagram. So let's say speed of light fiber. So let's say it's 2 lakh, right? 2 lakh kilometer per second. So light in fiber is 2 to 3 of vacuum. This is something very, very high, a value, just an constant value. So let's say there is a super speed in the internet. This is not the ideal value. And Bangalore to Virginia is 14,000 kilometers. So you should consider the geographically the distance between the customer and the deployed server. Then the RTT, the rate of transmission, and this is the real world. Some constant we have put here. So real world network have routers and congestion. So if you see any Wi-Fi throughout the all countries anywhere, so there are different nodes, there are many routers involved, then it goes and so on in the network. So you should have some kind of constant defined here with some values. You can explain these values. So these values are not fixed. You can consider like uh, something like relevant values. So let's say bandwidth typically 10 Mbps. You can say 200 Mbps or 100 Mbps. So it's up to you. So these are some constant you should define, and then image size is 1 MB, and image size in bits is 1 MB into 8 into 1024 and 1024. Because MB, right? So if I convert into bits, this is the conversion. So these many bits we need to download from the server. So if we see this, these are some steps without CDN. So first step is DNS lookup. So DNS resolving time is, let's say, somewhere 150 milliseconds for cross-continent DNS, because your customers reside in India and your server deployed in US. So you should consider some constant or some delay in millisecond for DNS resolving. Then TCP time for the handshake. Then TLS handshake for the securities. HTTPS. Your request is HTTPS. Right. So then this is the request, HTTP request time for real world. Let's say 0.5 RTT. So just some kind of constants you can add with that, and then your real world rate, transmission rate. Then server time, because server will process your request. Let's consider 50 milliseconds. Then this is server processing. After that, download time. So once your image is processed, you should give some downloading time also. So let's say 1000. This is downloading time. Then total without CDN will be your DNS time plus TCP time plus TLS time plus request time, server time, and download time. So this is something you should calculate completely, and then you can say this is the total time taken by without CDN. If you see here, this is overall. DNS lookup 150 millisecond, TCP 350, TLS handshake, let's say 700 millisecond. So these are not the fixed things. You can vary, but you should discuss the constant, because these are the things it's very important to consider. Then server processing, some time will take by server, then download time, and this is somewhere for downloading image of 1 MB, the calculation comes to 2264 milliseconds as per this data. This can vary for you based on the values you have considered. Now, if you talk about the with CDN, let's say your CDN is deployed in Mumbai. So from Bangalore to Mumbai. So instead traveling or like sending the request to Virginia, now you are sending request to Mumbai. Right. Then DNS lookup, Anycast to Mumbai, 10 milliseconds. Definitely DNS is required, right, to route the request. Connection setup, 0. Request, 6 milliseconds. So it's very near. Edge processing, let's say 1 millisecond. In download time is same. Like you can keep some download time there. Maybe depends on the network speed. So here we have considered bandwidth typically 10 Mbps. Let's say now your bandwidth is 100 Mbps. So this is 84 millisecond. Then we say total with CDN, because now we don't have now server, we don't have TLS handshaking, we don't have TCP. So you no need to calculate these things. All these things are 0 now. What are the things you should consider for CDN is DNS lookup and edge processing and download time, the actual time. Then if you see the difference between the latency without CDN is 2264 milliseconds, around 2.3 seconds. And if I talk about this with CDN, 101 millisecond, which is 0.10 second, 0.1 second, 2.3 seconds. See the difference. So this is the difference when you put the CDN there, and see the improvement 96% faster around. And the cost saving is also around 90% less origin bandwidth, because we are not directing that traffic to the Virginia. Let's say in Bangalore, we are saying a user as of now, let's say 1 million user are using in Bangalore, and your CDN is deployed in Mumbai. So that will also serve millions requests from Mumbai itself, instead of forwarding all the requests to our CDN. So this is where your interviewer will be analyzing your thought process and your understanding all over how a request gets sent from the client to server and what are the nodes in between available and what are the things you are putting in consideration. So how exactly CDN architecture looks like, as we discussed in this example, where we have considered DNS lookup and some edge processing and some of the processing time at CDN. Now let's understand this architecture, how exactly it works. So let's say user resides in India, then it requests for any resource and which is available in CDN, or it may not available at CDN. There are two possibilities. One is your resource R1, like image, video, audio, like any resource. It may be there or it may not be there. So how this call flow look like? Let's say you are calling at cdn.example.com. This is one of the DNS. Then DNS resolved the query. So query is, you will have a IP address respective to the DNS. You will have one IP, single IP, which is called Anycast DNS. So route to the nearest POP, point of contact, point of point. So what happens is, now there is a IP address associated to your DNS. Let's say 1234, 1.2.3.4. So now what Anycast IP does, let's say your CDN are deployed in Mumbai and let's say in Singapore and London, right? These are the three places where you have CDN deployed. So all these three CDN will have same IP at different location. This is how internally it designs. So there will be a query from DNS resolver, from DNS server to this IP address. Now if you say you are requesting from India at this address and the request went to Mumbai, Singapore and London. So if you see here, the response time from Mumbai is 5 milliseconds. The response time for Singapore is 80 milliseconds. And the response time from London is 200 milliseconds. Then the DNS resolver will forward the response from the nearest IP address. It will forward the response of this one, not this one. So there is another component internally that also I will discuss. So how this IP resolution will happen and then how this forwarding will happen. Then HTTP request to Mumbai Edge. This is how your DNS decides where to forward the request. So let's say you are requesting for R1. Now, first point is resolving the DNS. Now DNS knows, your DNS resolver knows where to forward the request now, because what is your CDN edge? So to identify that edge is, this is the way, like all your CDN have same IP, DNS resolvers and the request to all of your CDN deployed, and from which CDN you get the lesser latency or response time is faster, that is the one which will be eligible to serve for India. So now whenever you send the request, any HTTP request, then it will be moving to Mumbai CDNH, and you will always get the response from CDNS deployed in Mumbai. So this is how DNS resolver take the decision based on the Anycast IP address. Now, in case, let's say your resource one is not available in CDN, not here, not here, and not here. It's not available anywhere. Then the request will go. In case of miss, The request will go to load balancer, your original infrastructure. Then load balancer will forward the request to app server, and then you will get ob object storage. Like you are, let's say, if you are calling a video, or, no, or you are downloading a video or audio, so you have an object storage for that. So you're fetching it from the object storage and then returning back to the customer. So this is how the overall architecture look like when you have CDN layer in place. So now let's understand one problem is the cost problem in AI applications. So if you see any AI application, this is the common deployment way or the call flow. I'm using here one of the example of this website systemdesignhandbook.com just to show it. So let's suppose here is a client device where any user sends request. You are using ChatGPT or you are using Grok or you are using any ChatGPT like applications. Then at the back end, there is a load balancer who accept the request and forward traffic to the API gateway. And then this API gateway send request to the service mesh. So where the actual models deployed. This is the inference cluster and context storage. So you no need to worry about these some jargons and technologies. We will be discussing in detail in the other lectures. But now on top level, if you see, if you are using any API from LLM or you are using a model to process it, so there is a cost associated to it. So cost is two types of cost. One is if you are using an LLM API, let's say open API, the number of API calls per token. So if you see here GPT-4 API, if I'm using GPT-4 API, and this is the cost 0.03, this is basically cents, 03 cents for 1K tokens. So how the LLM works, any LLM API. So the larger request or the larger responses, the number of tokens will be used more. So let's say if you ask one question to LLM, to the chat GPT, if you say like this, um, let's say Gemini. If I use Gemini, if I say hello and just hello. So there is some tokens we are sending it to the backend. And then this is the response where we are consuming some tokens. So request tokens and response tokens. So if you see this is answer hello, how can I help you today? So there are some tokens which is being used to generate it. So the tokenization, embedding, and all these things we'll discuss in detail in other classes. But here to understand is this is your UI, this is the client, and this is the call flow. So this request somewhere it is going to the load balancer. Then this is the overall infrastructure works. So now the higher your request, the higher size of your request is, or the higher size of your response is, the number of tokens will be higher. Then the cost will be higher. So it's like, let's suppose you have average query 500 tokens equals to, so let's say any average query which consumes 500 tokens, the cost will become around $0.015. If I say I have customers, 1 million customers, and every day they are using my application, so 1 million queries per day. If I multiply it, then my cost of application for this API itself will be 15,000 per day. Right? So $15,000 per day to serve 1 million customers. Now, if I talk about the images, somebody want to generate image. So for 1 million image, I am using $10,000 per day. This is the cost for image. So if I do combined cost, then it will become 25,000 per day. And if I say my application is available a year to serve 1 million customers, the cost of my application of this API itself, GPT-4 API itself, is $9.1 million. This is so high, right? Because every time we are calling ChatGPT API, the GPT-4 API, right? So how the system will look like, let's say your client is sending request to load balancer LB, then LB sending request to server, and server is sending request to GPT. This is the flow, GPT 4.0, right? This is the API call. So every time whenever customer asks for any question to your application, the API calling is happening again to GPT. This is where this cost come to $9.1 million per year to serve 1 million customers. So this is a problem for you. You need to reduce this cost as an architect. So if I ask the same question in interview, so how you can design it better? So you can put a CDN, semantic CDN. So what CDN can reduce it? It can cache similar prompts. 80% of queries are variations of top 1000 questions. So let's say when you start caching the prompts in 1 million customer, there is a possibility where let's say 500 customer ask for similar kind of prompts. Let's say you have 1 million customer of 12th class students, or maybe let's say BTech student, BTech first year. Just an example. Now, BTech first year students are using your application for technical queries. So they will inquiry on C or system design or maybe compiler design, similar kind of queries. So there's a possibility out of 1 million customer, there will be some percentage of customer where the prompt is similar, right? So we can cache those similar prompts of queries and variations. Then the cached response cost is this one. So if you cache it, instead of calling GPT, we can return the response from here itself. So this is where you can lower down the cost, which will become around 150x cheaper. So now just doing one thing, just a small change, this can bring your cost from $9.1 million to 5,000 around. Like this is just an around values. So per day. So you are saving around $7.3 million per year just because of this small change. So this is where you are reducing the inference cost. Now how you can do that? So this is a solution for the same problem to reduce the inference cost. Now let's discuss this. Now here is the user worldwide. You have enabled your application throughout the world globally. And let's say these are the queries. Show me blue shoes, write blog about AI, and so on. So this is overall, like here, this is the space where customer is talking to your chat support, like how to return an item, or there are many inquiries or queries. Right? So basically it's a chat window. You can just think like that for your customers. Now they've started chatting, they are started asking the questions. So now we can place a CDN edge layer where we will put a smart router and it routes to cache, model, or GPU based on the complexity score. Now, how this complexity score can be calculated, it varies based on your business logic or defined logic. So this routing, like whether to I need to use cache or model or GPU, you can define a score for the query, and based on that score, you can fetch it. And another beauty of edge layer of CDN is you can put a lightweight edge model like ONNX or media pipe, like small model, right? You can deploy a small model there itself in CDN, and it will handle your 60% of remaining traffic. So let's say you are creating a chat assistant for banking. So any model which is trained for support, and if it is a small model, a lightweight model, that you can deploy at edge itself. So this will handle your customer's inquiry on your items or fixed like queries. This lightweight model can handle there itself. So we are not calling the external APIs or LLMs. So we are reducing the load here, and using the top 1000 request, using that technique, we are storing the response into cache. So there also we are distributing the traffic now. So let's say if your traffic is 100%, maybe 1 million requests, out of 1 million requests, around 60% of request can be served based on your use case, can be served from your small model which is deployed on edge. Let's say out of 100, 20% or let's say 10%. 10% request can be handled by cache, where you are storing the semantic cache, where you are doing the similar kind of that, the storage. So this is handled 10%. Now if you see out of 100% traffic, your CDN itself is serving around 70% traffic here itself. So now remaining 30% based on the complexity score, you are sending to your actual deployment, where you are using GPT or Claude or any stable diffusion for image generation, right? Or RAG pipeline for vector DB and LLM. So don't worry about these jargons and technologies. We will discuss in detail each and every topic. So here just to understand the things which cannot be served by your lightweight model, those will be forwarded. The remaining 30% traffic will be forwarded to serve either from API or models or RAG pipeline. Now, so instead of forwarding all 1 million requests to the APIs or LLMs or RAGs, here the cost is higher. This is the area where the cost is higher, and this is the area where cost is lower. So definitely you are diverting the traffic, or you are able to filter out the traffic, and you are able to lower the cost using CDN edge layer. So this is how any AI application is trying to use CDN edge layers. So in interview, if anyone asks about the AI application deployment strategy, my recommendation is please put an CDN edge layer, and you can filter out the request. I don't know, the user experience is also higher. So instead of giving response every time from here, the latency will be higher. The latency of CDN layer will be lesser. So you put this CDN as layer, have more discussion on this, and this will give you some fruitful results. So now here I have created a semantic cache for LLM responses. So always question is, whenever there is a query, and how we are creating this cache at CDN layer and storing the responses, because we are saying here the top 1000 questions. So how we are taking the decision and how we are storing into the semantic cache. So this cache is not the one where we are directly inserting the record, or we are fetching the record based on the 100% match of a string. So the query can be similar of the previous query. So that is where we need to use semantic search, semantic cache. So it is just an snap. I'll discuss on top level. I'll share this code. So the key concept here is embedding the similarity instead of exact key match. That is the one thing which we will be focusing on. And then tiered TTL based on the query popularity. So if you see here, it says TTL 1 hour for common and 10 minutes for rare. So this is also one of the most important thing. So I am storing or I am persisting in cache for 1 hour for commonly asked questions, and I'm persisting the data for rare asked questions for 10 minutes. So we are updating our TTL also based on the inquiries or based on the queries from your chat window. Now, then background revalidation for popular queries. So we need to revalidate that whatever we have stored, are we storing a relevant top 1000 questions? How the relevant is, how accurate it is. So we need to do that background job. So that is a background revalidation for popular queries. So I created one class, data class, and this class is having, these are the class variables like prompt, the input, and the response returned from your LLM. Embedding, I'll discuss this in detail in our ML lectures, how the embedding works, what exactly embedding is. But we are just storing in an array, small chunks. Then created at, we need the time. Then hit count also we are increasing. There's a counter which we will be maintaining for, let's say, if 1 million customers are using your application, if similar count of hit is there for the same prompt or similar prompt, we will increase the count. And last accessed. So this will tell us like how recently we have used. This will help us to identify the TTL here. Either I need to maintain a 1 hour TTL or 10 minutes TTL. So based on the last accessed data, we can try that. Then what we have done here is semantic cache. This is one of the class like I created, and what it serves, this is the doc string. So it serves the cosine similarity matching, tiered TTL, high traffic and lower cache, popular popularity based revalidation, and thread safe operations. This is somewhere like this is something it serves all these operations. So here we have init. So we are using Redis for the cache, and this is a connector, like we are connecting to Redis. These are configuration files or the parameters, and then we are initializing Redis just to store the data. Now these are some properties. So let's say get embedding will return your embedding. Similarity is somewhere we are maintaining the similarity using NumPy. So we'll cover this NumPy in our ML lectures. And here we are storing the generating a deterministic key for the prompt for Redis. So this key also we have to create and based on the prompt. Then finding the similarity. This algorithm for finding similarity based on your embedding or your candidate key. So this is something finding the similar data and then returning the key based on the best key or score. If there is no best score, then it returns, let's say, best key, whatever you're passing. And then here we have get cast response for the, this is the get call. So once you identify that whatever inquiry or the been done by the customer, it satisfy all your scores for the conditions like finding the similarity, and if satisfy all the conditions, then we are using get. We are fetching it from the Redis database. So you see here finding the most similar result and then Redis. Updating head count and check if should be removed for hot TTLs. So we are updating the TTL also. Then this method is set method to store the prompt response here in cache like key versus embedding. Right. So this is all over structure which we are storing into Redis. Like we are storing prompt, we are storing response, embedding, created at, hit count, and last access. So this is the overall data we are storing for the prompt. And then there are some compute and get stats. These are some monitoring things. So let's discuss this one. So we have one data. So that is the overall class above. Now this is one of the mock response. So let's say you have one function which is for LLM call. What it does is it simulates the expensive LLM calls. So whatever we are talking about here, so instead of integrating the real API of LLM, we have created a mock data, just a function. Okay, and what it does, it returns mock response. Then these are the prompts. The prompts are nothing. The questions you are asking, the questions being asked by user, that is we have created here just for demo purpose. So let's say the inquiries are, what is the best way to learn Python? How can I learn Python programming? I want to learn coding in Python. What is weather like today? So if you see above three prompts look similar and the response also will be similar. But for the fourth inquiry, this is very, very different from the above. So this is where we are saying semantic similarity match. So now we are processing these prompts for prompt in prompts one by one, and we are saying response equals to get or compute. So this is where we are calling this method, and what this method does, it get from cache or compute or store. So it takes the decision, like this is the decision, right? Either I need to fetch it from cache or model, or I use API. That is a like decision point here. So if you say there, if cache miss, if there is no data in cache for this, then store it. Self.set, we are storing it and then returning it back. So this is how you can just build a small system. Overall, how the semantic cache works, the design should be look like. So now let's suppose if somebody asks question in interview, similar kind of thing, how can you design a semantic cache or what exactly you need? So you can define, at least you should define the functions. This function will does this function will do this, not the actual implementation. At least you should define all the stages, all the functions, methods, and create a small demoable code where it is not necessary to use the real APIs or the real data. You can define some demo data. So the interviewer, they validates your answer, how you are thinking. They don't validate the actual output of the code. They validate your thought process. They validate your the way you are writing the code or the way you are writing or you're thinking or designing it. So I'll share this code to you. So this is one of the interview most frequently asked question from CDN. The question is, how does Anycast DNS actually work at the network layer? So what the meaning here is, as we have discussed, there is a single IP assigned to multiple CDN servers. So if you see here, Anycast uses BGP, Border Gateway Protocol. This is one of the protocol. They use that the same IP address, for example, 1.2.3.4 is announced from 200 plus locations. BGP routers see multiple paths to 1.2.3.4 and choose the shortest as path. This automatically routes user to the nearest point of presence. So this is where a smart technique or a BGP protocol used by uh, CDN. So all of your CDN will have same IP address, and then as you see here, a DNS resolver, it calls the same IP. Here it calls the same IP and then get the response back, and based on the response time it define which one to use. So that is the same thing here also we are doing. So announced from, so let's suppose you have user in India and you are asking for some resource available in CDN. So one CDN is enabled in Mumbai, one in Singapore, one in London, and these are the three. So, and the IP address assigned to all these three is same, like Mumbai, Singapore, London, right? And there is a as path and hop count. So let's say hop count 2, hop count 3, hop count 4, 5, 6, and any hop. It can have n number of hops. Now, if user ask an inquiry, then the same IP address will be used to fetch the data from the CDN deployed in Mumbai. If the user is from Singapore, then this is the CDN will be used for them. If you are in Europe, then this is the CDN will be used for them. So this is where DNS resolver or the BGP protocol, they uses the Anycast BGP protocol. Based on that, they can easily able to define from which CDN I should be able to serve for this customer based on their geography. So this is the one question. And another thing is we have already discussed this also. What happens when a CDN edge server fails? So the answer is multiple layer of resiliency. So you should maintain the multiple layer of resiliency. One thing is Anycast auto reroute. So let's suppose Mumbai is down. You can serve customer from Singapore. This is where we are talking here. So BGP withdraw the failed server route. Traffic flows to the next nearest edge. Then it maintains health check also. So it's not about like we are checking only that time when we are getting request from client. So it always check the health check. There is a pattern called circuit breaker. Maybe you can read that. So this pattern says it will continuously check the health of each deployed edge server, and in case of unhealthy server are removed from the rotation in 30 seconds, less than 30 seconds. So let's say the frequency of check, the health check is 30 seconds, and if we are not getting there is no heartbeat here, then it will remove from their list. It will not call it. So it's not like whenever customer is calling API or calling to the CDN, then only it checks. No, it keep on checking the health of each edge. In case one edge goes down, it update its routing table and it will use the available edge. So it will not call again here until this is up. So that this is where it optimizes the request also. So this is we have written here BGP routers automatically choose shortest as path. User reaches the nearest edge. Right? And then the third thing here is cache redistribution. So other edges may have the content or fetch from origin. So there is a possibility, let's suppose, due to some issue, this CDN is not in sync, right? This is not in sync. And this is in sync, this is in sync. So the latest data is not available here. Then who is responsible to update this? This is question for you. So now let's build your own CDN. So this is where I created just an code snap for the demo purpose. And whenever you have a CDN discussion with your interviewer panel, you should be focused on these features. And in fact, you will get a lot of questions on these features. So let's say you need to create a production ready CDN client. And these are the features should be implemented into it. So first thing is multi-CDN support with automatic failover. Then circuit breaker pattern, where we have discussed, we keep on checking the heartbeat of the available edge. We call the API and we get the response based on the frequency which we have defined. Then connection pooling with HTTP2. This is also like kind of circuit breaker, but here we have direct API calls, and the polling method is where we have a defined period. So after defined period, we call the API again and then we analyze the response. So polling method we implement in the CDN client. Then automatic retry with exponential back off. So you should have an automatic retry mechanism. So let's say once you are calling the CDN and due to some network issue or maybe some another foreseen incident is you are not able to get the response. So you should give a retry automatically. Then some cache warming utilities and comprehensive metric collection and graceful degradation. In case something goes wrong, you should be degrading to the another route gracefully. So those are the scenarios you should be discussing with your interviewer, and where the interviewer will understand the how you think for CDN, what is your thinking, not only just placing a CDN technology in your application. What are the things we should keep in our mind as a best practices when we are putting any CDN client in the front end. So this is one of the code snap, and I'll discuss class level. I'll not go in deep with. So here we have a cache status, and this class will maintain some of the enums. So we are using an enum here, and these are the constant. Let's say hit, miss, revalidate, stale, origin, or error. These are the different types of status we will maintain, and this is for circuit state. Let's say how the circuit breaker will work, right? So it says your connection is open or half open or closed. So we have defined some constant for that, and then here's the response, CDN response. So this is just an standard response where we have content which is in byte, the status code, maybe the then cache status, latency in milliseconds because we have to maintain the latency of each edge. What is the edge location, right? Either your um, cloud, the CDN is deployed in Mumbai or London or Singapore, right? The location, then CDN provider. So there are a lot of CDN provider in market. So these are the CDN provider. So we have Cloudflare, CloudFront, Akamai, right? So these are some use cases where you can decide which CDN to use. So let's say if you have a general web application, any general purpose, not a specific. So you can opt for Cloudflare or CloudFront. These are the CDN tech available, providers available. If your application is highly on video streaming, then you can use CloudFront or Akamai, and Fastly is also available. For AI/ML model survey, Cloudflare Workers plus R2. Cloudflare, Cloudflare is the best for AI/ML model survey. Then for enterprise security, let's suppose your application is banking application or healthcare application, some enterprise level applications. So the recommended is Akamai and Cloudflare. And real-time applications like some of the real-time streaming, or I would say real-time update if you need, then you use Fastly. And budget friendly, if your budget is low, you can use Bunny CDN and Key CDN. So these are some of the cloud CDN providers. So if I say here Akamai CDN, so you will be able to understand what exactly this CDN provides, what are the features. So you can read their documentation. Similarly, if I talk about the cloud front, so this is also one CDN. This is developed by Amazon AWS. And if your application is deployed at AWS, you can use CloudFront. So if you see here in this table, the CloudFront is suggested for video streaming and your general application, general purpose. And there is another is Cloudflare, that is another company. So Cloudflare, CDN. So this is another CDN available. So like that. So there are a lot of providers for the CDN. It's up to you which you want to use. This is some of the recommended CDN based on the use case. Similarly, here this is the value where CDN provider can fit in. Let's suppose you are using Akamai, so you can add Akamai here and some header details, header of your request, and from cases true or false. So this is one class which is implemented for circuit breaker on CDN failover. So if you see, there are a couple of variables, or we call it attributes. So it says failure, let's say failover thresholds and recovery timeout, half open max request, states we are maintaining if your circuit is closed or open. So it's a design pattern. I'll discuss circuit breaker in one of the in lecture. We will be able to understand how the circuit breaker works. But as of now, just think like it's keep on checking the availability of CDN, and if it is available, the connection is open, the circuit is open for making the API calls. If it is closed, means you are not allowed to do it, and there is a half open also where we allow a limited resources to access. So these are some of the methods implemented in this class, circuit breaker class, like record success, record failover, and then allow request. So if your so see here, this is the condition. If your state is open, so it says allow request. If state is closed, return true. If it says if your circuit is open, means your circuit is braked, right? Means if your circuit is open, means braked. So think like an electricity wire. So closed means it's connected. So now if you see here, there is a half open and then we are allowing the request. Then we have CDN endpoint where we will have like detail of CDN endpoint. So you can create many objects of this class, and these objects may contain the different values, name, base URL, origin URL, priority, all these things. And this class is CDN client. So where we are initializing the CDN. So this is a multi CDN client. So client is the one who is using CDN, right? See here uses. We are creating the object of CDN client and we are adding CDN. So there are two CDN we have added. Add CDN CloudFront. These are the details of the CDN. And again, we have added another CDN, which is this one. And then response, we are trying to fetch hero.jpg from the client, from the CDN. So there are two CDN we have added. So now see here, you can go through this code, how add CDN works and how we are getting the response back. I'll share this code with you. There is one thing which is purge. So let's suppose some resources are not being used since long time, or based on your policy for the cleaning the data. You can define, you can purge that those resources. Let's say some images are long pending images you have uploaded into CDN, let's say last year. Now nobody is using it. Then you need to purge the data. So that is like maintaining the CDN up to date. So this is start health check endpoint. It checks the health check. It calls the API, and if API is success, then it's update. It's healthy. The status is 200. If the status is not 200, then it says healthy is false. So like that. This is a circuit like kind of we are doing pooling here. So this is one of the example uses. Like we created a CDN client. We added two CDN, and then we say client dot start health check. So we are checking that the CDNs are available or not. If CDNs are available, then this is our path. Like we are looking for these resources: HTML file, a JPG file, a image, or some products, or let's say some JS JavaScript files. So these are the some paths we are looking for, and each path here we are saying for path in paths. For each path, we are calling the API. We are saying client.get. So this get will call to the CDN and get the data back. And then we are creating some metrics here, get metrics report. And then finally we are saying client.close. So I try to run this application. I don't have this module. I'll install it like pip3 install httpx. So you can install the modules, whatever modules been used. So you can see here on top. So whatever we are importing here, these are the modules. So this is one of the module which I have installed. So it will throw an error if you run this file. So you just install all the modules and try to run this file. So you will be able to understand in detail. You will be able to run it. So my suggestion is go through the code. You use AI to understand code and each method, and then see how exactly how we are implementing all the above features as we discussed here. And another thing to discuss in interview is on monitoring side. So track your CDN performance. This is one of the important point to discuss in interview when we are talking about the CDN. So we need to talk always about the CDN performance, how we can measure the performance. So let's say something goes down. Are you monitoring it? Or what is the performance? Let's suppose for the last 3 months or last 2 months, how it is behaving. Is really CDN is helping our customers? So there are a lot of questions around to that. So that is where the performance matrix comes into the picture. So these are the some of the attributes you can think about, like number of like requests, number of hits, how many misses, how many errors, what is the latencies, right? It's a list, and the locations. So you should have all the metrics for the tracking purpose, and then talk about the P50, P99 latency, and there is a like we call it P99, P95, P90. There are a lot of parameters where we monitor the latencies. So what is P99 or P50? So this is a value like 99 out of 100 requests. Just an example, out of 100 requests, how the what is the performance of 99 requests? Right? What is the latency of that? So we just so if you see this P50 latency, what it says, if not in self dot latency, then return 0 means there is no latency. If there is a latencies available, we are figuring out the medium. The median value is the response time for 50% of the request. We can just translate in that way. So it's a like similar kind of thing. So here, if you see, so let me run it. I think this is working or not. So it is not printing anything. Ideally, it should report, it should run. And so let's say we are creating this and report. So I'll call it matrix dot report. So maybe it just what it says, it returns. So I'll print it and see the output here. So you can get the calculations done. I haven't called other methods. I just printed this method. So you can call the method one by one, and let's say you want to record some status. So here are the some of the things you need to pass. So just it's a demo purpose. But whenever you are integrating a monitoring tool with your CDN clients, so you need to integrate their, either you can integrate with their SDK or using their library, right? So you should be integrating any monitoring performance monitoring tool with the CDN. Or if the providers provides it, you should use that. And don't forget to mention it in your interview. So these are some best practices for implementing CDN. Here CDN is a massive distributed cache. The This is like takeaway basically all over. So the takeaways is CDN is a massive distributed cache, the outer layer of caching hierarchy. Yes, because client directly talk to the CDN. Master cache control headers, they control everything. So based on the headers, based on the different variables available in header, we can control the flow of the CDN, like which CDN to call, what are the things we need to call, what are the things we need to purge. So there are a lot of variables available in header. You can use that. For AIML workload, we have special CDN needs like semantic caching. So we have understand that semantic caching. Maybe you can have more understanding on edge inference in model distribution. These are the two other topics you can read through, or once my AI ML classes will be there, I'll discuss these two things, how the edge inference works and model distribution. Design for failure. So this is something we should be keep in mind whenever we are designing a CDN. CDN should work even when origin is down. This is a great point. Let's say your server is down, but your CDN should work. So your application is not 100% down. It's somewhere maybe we can say 20% services are not working, which is very depend on your server, or the data which is available in CDN that is suffice to serve the no, some of the customers. So this is one of the benefit. Monitor everything: hit ratio, latency, error per region. This we have discussed. Security at edge. So this is also one of the benefit. We have DDoS attack, we have WAF, we have signed URLs. So all the security prospects are covered here. They provides. Then edge computing is a future run. So is the future run logic closest to the user. So this is where industry is thriving to. So instead of processing so far from the user, if we can bring all the logic, all the data near to the user's device, and we can serve a better user experience. This is here like CDN engineering career path. So in industry, just to maintain or manage CDN, there are a lot of jobs available in market. They take care about the CDN only. So if you see here, entry level, if you have 0 to 2 years experience, you can you can go in networking, you can have CDN basics and monitoring. But when it comes to the mid level, then you should be thinking about the performance optimization, what are the securities, like multi-CDN architecture, all those things. And when you are more become more senior, then think about like design global systems for like 100 million customers, AI/ML integrations, how you will do that, and cost engineering is also one of the aspect. And when you are a principal or architect when you have 8+ years of experience, then industry standards, innovation, leadership, all these things are additional thing you should be having. So this like all over aspect. So if you have, let's say, 10+ years of experience, you should know each and everything of this. This is what industry is demanding nowadays. So this is overall about the CDN. If you have any question, any interview question you want to discuss with me, and you want to have some mock interviews, we can have that. Please ping me in a comment. Thank you for watching.